Hey there, sixth graders. We are going to continue studying ratios. Now, yesterday we talked about three different types of ratios where you have a part to a part comparison, a part to a whole comparison, and rates. We're going to look specifically at ratios for today. We're going to clarify a lot about the different types of forms that we can use with ratios. So yeah, let's just jump right in. So what is a ratio? A ratio is a comparison of two quantities. Remember, quantities are numbers. Quantities, ES, by division. So that's the operation we're going to use to compare these two numbers. We're not going to multiply them together, we divide them. And a ratio can be expressed in three ways. And what I love about this first way is it directly relates to division. We have fraction form, which makes all the sense in the world because, as we already know, a fraction bar is a division symbol. We can use a colon, which are those two dots, or we can use the word two. We could use the word two, word form. So let's look at an example. So in Mr. Tolentino's class, we have 4 girls and it appears to be 6 boys. So we want to know what's the ratio of girls to boys. Now, as we're going to explore, order matters. So we're specifically saying girls first compared to the boys. So when we are writing our ratio, we need to make sure we put the girls first, then the boys. If it said what was the ratio of boys to girls, we would flip-flop that order and we would put the boys first. But this specifically says girls first, then boys. So in fraction form, we have 4 girls to 6 boys. And I do want you to label. Using a colon, we have 4 girls, colon, 6 boys. I'm just going to abbreviate using letters. And then the word two, it would be 4 girls to 6 boys. I think ratios are easiest to understand when they are in simplest form. So therefore, we are going to simplify our ratios, which would be the same as simplifying fractions. So if we were to simplify this, 4/6, well, we can divide them both by 2. What this means is that for every 2 girls, there are 3 boys. So we're simplifying that ratio. Let's take a look at what that means. So what this means is for every set of 2 girls who walks into Mr. Tolentino's room, for every 2 girls, there will be 3 boys. So that's one set of 2 girls and there are 3 boys. Here's a second set of 2 girls and there's a second set of 3 boys. So that's what it means when we're simplifying that ratio. We're breaking it up into smaller groups. We're simplifying those ratios. So let's talk about ratios versus fractions. Is the ratio above in fraction form? Is that actually a fraction? Now remember, a fraction actually represents part to a whole thing. Now, if I'm comparing girls to boys, is that comparing part to a whole or part to a part? And the answer is this is a part to part comparison. So the answer here is no, it's not a true fraction. Why not? Because this is a part to part ratio, not a part to whole ratio. And in order for it to be considered a true fraction, it would have to be a part to whole, which in this case it is not, which is why we're not considering it a true fraction. But could we turn the part to part into a part to whole? We absolutely can. By comparing, we can do that by comparing to the whole class. So we could turn the part to part into a part to whole by comparing the number of girls to the whole class or the number of boys to the whole class. So let's just go with comparing the number of girls just because they show up first. So the part would be, we have 4 girls to 10 total students. So in a fraction, that's, if we simplify this, so this is, we're going to simplify at the end, sorry. So that's 4 to 10, which a simplified fraction would be 2/5. And what that means is that for every 2 girls, there are 5 total students. So for every 2 girls, there are 5 total students because we have 4 and 6 up here. That's 10 total students. Whoops. And so that fraction would be 4/10, which means for every 4 girls, there are 10 total students. Ratios with different units. Let me change colors here. Ratios with different units cannot be converted into fractions because what you're doing is you're then comparing 2 totally different things, so it would never be a part to a whole. And these are what we call rates. If you have 2 different units, they're called rates. So here's some examples. We could say for every, you have 2 boys and you have 4 pencils. Boys and pencils are totally different things, so that would be a rate. We have, let's say, 50 miles for every 2 hours. Miles and hours are totally different, so therefore that would be considered a rate. You could have, I don't know, come up with your last 2 examples. I guess I'll come up with one more. You could have, let's say, 6 parents for every 10 pieces of candy. I don't know. So if these are 2 totally different things, so this would be considered a rate. Come up with your own example. All right, let's flip over and look at some more examples of ratios. So we're going to write the comparison as a ratio in the 3 different forms. And then we're going to see if it's a true fraction or not. And remember, a true fraction has to be a part compared to the whole thing. Okay? So in fraction form, if I have 1 ball to 6 players, this would be 1 ball over 6 players. Colon form would be 1 ball, 6 players. I'm just going to abbreviate. So this would be 1 ball in word form to 6 players. So those are our 3 forms. 1 ball compared to 6 players. Is this part of something compared to the whole thing? No, these are 2 totally different things. So this is not a fraction. And because they have different units, that will never be turned into a fraction. They would have to be like similar things. It would have to be like 1 boy to 6 players, and then that would be because the players can be boys. So those are somewhat similar. Okay, this next example is interesting because we have walking TVs and walking dog houses. So we have, let's see, 1, 2, 3, 4, 5 TVs to 3. I'm just going to put H for houses. I could put DH for dog houses. Colon form would be 5 TVs to 3 dog houses, D for dog house. And then the word form would be 5 TVs to 3 dog houses. Is that a fraction? If I'm comparing 5 TVs to dog houses, is that part of something compared to the whole thing? The answer is no. Can it be converted into a fraction? I mean, I guess you could if you're going to say, hey, there's 5 TVs out of 8 total walking items, but these are actually different, so I'm going to go ahead and say, no, we're not going to turn that into a fraction. Let's look at another example that maybe will be turned into a fraction, perhaps, or maybe is a fraction. We'll see. 8 boys to 20 class members. So we have 8 boys to 20, I'm just going to call them students in general, to 20 students. So this is 8 boys to 20 students and 8 boys to 20 students. Okay, if I'm comparing the number of boys to the total students, is this part compared to a whole thing? Do the boys represent part of the class, and does this represent the whole class? The answer is yes. Finally, that is indeed a fraction because you have part of the class compared to the whole class, so we can consider that a true fraction. 6 A's to 14 B's. Let's take a look. 6 A's to 14 B's. 6 A's over 14 B's. 6A colon 14B. 6 A's to 14 B's. I'm comparing A's to B's. Am I comparing part of something to the whole thing? The answer is no, I'm not. Because I'm assuming there's C's, there might be some D's. So this doesn't represent all of the grades. This represents just another part of the grades that a class obtained. But can it be converted? Yes, it can. If you did, let's say, 6 A's to, I don't know, 25 total grades, that is now a fraction. If we're saying, hey, 6 of the students got A's out of 25 total students who took the test, that is now a fraction because it's part to a whole. 60 miles on 3 gallons. Okay, so that's going to be 60 miles, MI for miles, over 3 gallons. So that's 60 miles to 3 gallons. 60 miles, word form, 3 gallons. Okay, if I'm comparing 60 miles to gallons, will miles and gallons ever be the same thing? No, they will not. And the answer is no, it will never be a fraction because this is a rate. Because we have 2 totally different units. That would be a rate. Miles per gallon is a rate. I'm going to do one more with you, and then I want you to finish the rest on your own, and you can check my completed version to check your answers. 12 completions and 20 total pass attempts. So, oopsies, we have 12 completions, 12C, over 20 passes. So 12 completed out of 20 passes. So this is going to be 12C to 20P. So that's 12 completions to 20 passes. In word form, use the word to. So 12 out of 20, is this part and is this whole? It is. This is a fraction. It is part of something compared to the whole thing. That is a part to whole comparison, so it is indeed a fraction. Like I said, I want you to finish the rest of this on your own, and then you're going to check my answer key on the website. But in the meantime, let's flip over and let's do this top part together, and I'm going to have you finish the rest on your own. In an orchard, there are 150 orange trees and 250 apple trees. Okay, so we have orange trees and apple trees. Got it. In simplest form, what is the ratio of orange trees to apple trees? So I have 150 orange over 250 apple. So it's an O and an A, orange and apple. Let's see, I can divide them both by 50. And I get 3 orange over 5 apples. So for every 3 orange trees, there are 5 apple trees. In simplest form, what is the ratio of apple trees to orange trees? Okay, so now we have 250 on top because order matters because we're doing apples first, oranges second. So oranges will go on the bottom, 150 oranges. So again, we divide by 50 over 50, and we get 5 apple trees to 3 orange trees. In simplest fraction form, what is the ratio of orange trees to the total? So now these are going to be true fractions. So what is the total amount of trees? Well, 150 plus 250, that's 300 plus an additional 100, so there's 400 total trees. Okay, so we're looking at orange compared to the total, so that's going to be 150 orange over 400 total, T for total. Again, I'm going to divide by 50. And I get 3 orange trees for 8 total. So for every 3 orange trees, there's going to be 8 total. In simplest fraction form, what is the ratio of apple trees to total trees? Okay, so now we're going to take that apple number, which is 250, and we're going to throw it over 400 total. I'm going to divide by 50, and I get 5/8. 5 apple to 8 total. A for apple, T for total. Okay, so which ones of these are indeed fractions? C and D. And why are they fractions? Because it is a part to whole comparison. So that's the big key. That's what allows it to be called a true fraction. All right, I want you to go ahead and finish the rest of this up on your own and check your answers on the website to make sure you did it correctly.